Welcome to Screen Deep, where we decode young brains and behavior in a digital world. I'm your host, Kris Perry, Executive Director of Children and Screens. Today's conversation explores how brains are shaped by early experiences, including reading, storytelling, screen exposure, and even the presence of a smartphone. Our guest is Dr. Tzipi Horowitz-Kraus, a cognitive neuroscientist whose work sits at the intersection of brain development, literacy, and digital media. She is an associate professor in the Faculty of Education in Science and Technology and Faculty of Biomedical Engineering at the Technion, Israel, where she leads the Educational Neuroimaging Group. Using tools like fMRI and EEG, Dr. Horowitz-Kraus studies how children's environments influence brain structure and connectivity, from white matter changes linked to screen exposure to differences between print and screen reading, parent-child brain synchronization, and even children's neural responses to AI like ChatGPT. Let's get started. Zippy, you are at the forefront of using neuroscientific techniques to measure how children's brains respond and possibly change based on exposure to screen-based media. You've authored or co-authored a significant number of studies that touch on both brain activity and actual brain changes in children from media use. Let's start with your findings that relate to young children. You have a 2020 study on preschool age children and structural changes to the brain. Tell us about how you measure these changes, what you found, and how parents can leverage that information going forward.
Wow. So first of all, let's just talk about neuroimaging for a second, because maybe for the average person, it doesn't really make sense. Like, how can we use MRI that is usually used for, you know, imaging, take an image of your stomach or your leg or your knee or maybe even your brain, looking at the structure of it. What we're doing in research, we're able to look at the functionality of the brain by measuring blood flow that goes to active regions, which means that I can basically ask a child nicely to lie down in this big machine, and with a specific code, I can provide an information about regions in the brain that are active or less active in relation to, for example, screen time exposure or a specific activity on the screen. In relations to this 2020 JAMA Pediatrics paper, we did not look at the function of the brain, but we looked at the structure of the brain, and not only the structure, but actually the white matter tracts, these roads that connect the active regions in the brain. And we looked at how screen time and the nature of the use of screen, which means whether children are using screen interactively with their parents or separately. Do they have any TV in their room or not? Do they have a personal smartphone or not? Whether this accumulated number of screen time hours and interactivity or less interactivity is related to the structure of their brains. We worked with 3 to 5 year old kids, and what we found was that increased screen time use and less interactive time of screen use, meaning the child is using it on its own without the parent, was related to less organized roads. So white matter tracks, less organized, which means that in these roads, information is flowing from one region to another. If the regions are not organized well enough, the information doesn't go from one region to the other smoothly.
Can you help us understand a little bit better about these regions and the structural integrity of them? You mentioned brain matter, there's white matter, there's gray matter. How does all of that support language and literacy skills?
Oh, wow. This is a huge topic, which is so dear to my heart. So, there are several key brain regions that are related to language and reading. That for me, these are the most basic communication skills that we have as humans. And these brain regions are located in a very diffused way in the brain. Some of them located here in the front that are related to paying attention to what I see. Some of them located here at the back that are related to what I see. Do I see letters? Do I see people? What is it? And some of them are related to the sound of these objects or letters that are located here next to my ears, located in the left and the right side. For language and reading, it is mainly located in the left side for those who are using their right hand or right feet to kick a ball or to write. Now, the information in these very complex processes needs to move from one region to the other very, very quickly. When it's not moving quickly enough and there is no synchronization, which is a word that I really like, which means harmonization, harmonized movement between regions. If it's not synced, then we start having some reading problems or language delays. Now, if we're talking about flow of information between these regions, and these were just an example for a very complex activity like reading or writing or speaking or understanding language, if the flow of information is not smooth, we get delays. We get slow information processing. We may get some delays between seeing a letter and matching the sound of the letter to the letter that we're seeing, which is basically language and reading delays.
So let's dig a little bit more into these structures and the structural changes that may be made based on the child's interaction with screens or other media. I'm focused on these early ages and these initial questions I have for you. So, are any of the changes that happen in the early years permanent, or are there opportunities for the speed with which information is traveling between the regions? Can that be addressed? Can parents and providers do things to improve that for kids?
I love this question because when we talk about our brains, especially of young children's brains, everything is plastic for good and bad, right? Because if we expose the child to negative environment, that obviously can have devastating results in the young brain. However, we do see in our studies that it is flexible. The brain can be rewired, by the way, even at the age of 99, but it's easier to do when children are young. So if the child was exposed to massive screen time with the appropriate changes, I believe that the child brains can readapt itself to a screen-free brain, although we have not looked at that yet. This is something that we still need to look at in research.
Gray matter and white matter play different roles in our behavior and cognition. The 2020 study we just talked about looked at changes to both areas of the brain. You mentioned you have other research on children and how brain activity or connectivity changes due to exposure to screen media. Is brain activity and connectivity the same thing?
So activity of regions means increased blood flow to specific brain regions. We're talking about gray matter as opposed to white matter that we talked about earlier. White matter are the roads that connect different regions to each other. The regions themselves are built of gray matter. So if we're talking about brain activity, that is also measured using MRI or fMRI, which is functional MRI. We're looking into a signal that is generated by increased blood flow to active regions. When we're talking about connectivity or functional connectivity, we're talking about a synchronized activity between different regions. So basically, I'm asking whether when this region is active as well at the same time. This is functional connectivity. In most of our studies, we are interested to look at functional connectivity because synchronized activity is related to very much more complex behaviors, human behaviors, and cognitive behaviors.
How do preschoolers' brain activities change based on screen activity? In other words, you mentioned blood flow and you talked about being able to see that with an fMRI. In a preschooler, what did you see when they were on a screen? Or did you?
So, in preschoolers and overall, it is really hard to put a screen in the MRI. I mean, it is very, very challenging to put either a screen or a book in the MRI, for that matter, because it's a long tunnel, and technically it is very hard. But we use a very interesting manipulation where we try to see if watching a video, a movie on the screen is the same or different by means of engagement of brain networks related to visual processing or imagination and attention and language processing compared to a situation that is very, very similar to reading a book. Now, as I said, I cannot hand in a screen or a book in the MRI, but I can mimic these two situations. So, children lay down in the MRI. We showed them a video, basically a movie of a fireman doing this and that, and a parallel condition, another one, that they only saw some animated pages and heard a narrator telling a story. And that condition mimic the condition of someone telling you a story. And in other words, we wanted to see if there are differences or similarities when children are watching a video, a movie, versus listening to a story by a narrator. What we found struck us because what we found was that kind of counterintuitive. When children were watching a video, their visual regions, they actually saw people moving in a video. Their visual regions were functionally connected less to attention regions compared to when they were listening to a story. Now, when we looked at that afterwards, Dr. John Hudden and myself, the co-author on this paper, we thought, you know what, this is actually makes sense because, sometimes when you watch children watching television, you see their eye gaze start kind of glazing, like they're not really engaged in what they're seeing. I think this is what the brain tells us. There's less engagement and less need to even imagine anything because everything is handed to you. You don't need to work hard in order to be engaged in the story. On the other hand, when someone is telling you a story, if you cannot imagine it, you're not really engaged in the story. So your brain really needs to work hard. And the regions that are engaged are the visual regions that are related to imagination and the frontal regions that are related to directing your attention to it.
I feel like this should be a New York Times headline that when you studied brains of young children who were watching something, their brains were less active than if they were hearing something and essentially conjuring up that imagery themselves. I mean, it must have been a huge aha moment for you when the data came in and you were able to see these differences and had to figure out it's counterintuitive that this is the case. Wow. In this same study that you're talking about, didn't it also show that a group of children who were watching a video on screen were showing similar patterns to ADHD brain activity patterns?
So their brains were the attention network that I was talking about networks earlier, the attention network was less engaged. So I'm not sure, to say that they are comparable to ADHD, to kids with ADHD, that may demand to have another group of ADHD children diagnosed with ADHD to compare it to that group. But I would say that the attention level was lower. They had a lower attention engagement when they were watching a video. And I have to say here, think about ourselves in a stressful situation. It is really, really challenging to grab a book and to really dive into the book because you need to work hard to kind of build up a story in your brain for it. However, if someone kind of feeding you with all the information, your brain is kind of lying down, right? You're kind of resting. This is what's happening when we're watching TV or any kind of TV series. It is less demanding for our brains and, of course, for the young brain as well.
I mean, some of my fondest memories as a young child was bedtime and my mom reading out loud to us. from books that were too hard for us to read at that time, but it would paint these amazing pictures. I remember The Secret Garden and Charlotte's Web and Stuart Little and just picturing these characters and all the places they went to and all the things that happened to them. And I don't have the same intense memories of television shows I watched, although I do, but it's really fascinating to understand that what the brain is doing behind the scenes to get you to try harder and then perhaps increase your overall experience and memory of that story. So it seems like this overall research is showing that attention is highly affected by the form of the media that you're using. So is that true? That attention is really affected by what you're ingesting, whether it's print media or visual media?
Wow, now it takes me to another set of studies where we use EEG. EEG is another neuroimaging tool. It allows us to get information of how the brain is active, but in slightly different way. In that case, we put some fabric caps on children's heads as well as on their parents, and I'll explain why. But these caps have electrodes, and the electrodes on the caps, they do not transmit anything, they record brain activation. And as I said, electrical pulses are running from one region in the brain to another region in the brain, and that electrical signals can be recorded on our skull. So, using this methodology in a very unique way, by placing one cap on the child and another cap on the parent, we wanted to see whether there is a joint attention when parents are reading stories through a tablet versus when they're reading stories to their child using a printed book. And as you said, is it different or is it similar? So what we found very interestingly is that when parents are reading books to their kids in a very dialogic, interactive way, through the tablet, there was a decreased level of joint attention. The way we measure joint attention is whether the brain of the child, the signals are synchronized with the signals from the brain of the parent. And they were less synchronized when they read together from the tablet versus from the printed book. And there was another why. Like, we understand that maybe the tablet is different, but why is it so different? And when you look deeper into the videos, because we videotaped everything, we go back and we look at the behavior, we see that when a parent reads a book to the child through the tablet, the story is less interesting. It is about the tablet. So the child want to hold it. The child want to start to try and zoom in and zoom out, although there were no notifications and there was the book, it wasn't like an electronic book or any fancy story. It was the same version of the story with a PDF. So very, very simple. But yet, it's about the tablet. It's about the device. And that redirected the attention of the child from the bonding, which I call togetherness. It's the very special time that you mentioned earlier, to the device, and the joint attention went down.
We know that this joint attention is extremely important for cognitive and emotional development in early childhood. How do these results reconcile with other research showing that there are improvements in learning when parents and children co-view media? Are there different processes?
So during co-viewing, if co-viewing is interactive, then we're talking about something different. The interactivity between the parent and the child, the joint eye contact, the close relations, the back and forth that the parent and child have when they jointly active in a specific activity like book reading, for example, or anything else, that triggers some specific regions related to joint attention and language and so on. So even co-viewing, if the co-viewing is interactive, then it has some added value that passive viewing does not have. And it's very, very important to remember that, because that screen that we're holding, whether it is a tablet or a smartphone, it is not a babysitter. You don't just hand it to your child. You need to do something with it, with your child, and then it becomes a joint activity.
Based on your research on preschool age children and reading, what's the best way to approach helping children to read and promote important skills for school readiness like attention and self regulation?
I think that the answer to this question is going back to dialogic reading and joint reading because parents basically provide the foundations for future academic skills. You want it or not, you're there with your child, you're the first person that the child sees and the first person to speak to the child. Now, reading and joint reading is a way of exposing the child to a very complex system that is not intuitive. The writing system, the alphabet is not intuitive. It doesn't make sense. Sometimes I show to my students and in different lectures, different writing systems. And I tell them, what is this letter? What sound does it make? And people look at it and like, we don't know the system, this writing system. I'm like, right. And even if you started it forever, it will not come out because someone needs to teach you this information. The parent is the first agent to do that, the first person to tell the child the story and to point at the letters with their sounds and to look at the child while doing that. So the time that the parents spend with their children, exposing them to books, to games, even games with songs in the bath, like when they're bathing their kids. This is very, very important. And this is the foundation for attention and self regulation. Because when you ask a question, when you ask your child a question while reading a story, you're pausing for a second, and the child knows that they need to wait to provide an answer, right? So this is a self-regulation activity with a very simple activity of reading stories to your child.
So much of learning is social. So much of it is based on caring and knowing that someone's investing in you. It's also the instruction itself. I really am so glad you bring up that combination and how powerful it is. Even if you're co-viewing a tablet, that's better than doing it alone. And so I think it's really interesting to bring that up around younger children. But going beyond preschool age children, for older children who are already able to read on their own, there's an increase in reading screen-based media as opposed to print media in recent years. What are you finding in terms of how young brains react differently to reading screen versus print?
Yeah, so we had the first study looking at screen time versus reading time in 2017 or 2018. It was very preliminary because it was one of the first studies to even look at screen time and brain activation. We found that increased reading time versus increased screen time were related to greater, when kids read more, we found increased synchronization or functional connectivity that we talked about earlier between brain regions that are related to seeing words here in the back of our brain and brain regions that are related to language processing and to cognitive processing. And that kind of made sense. However, when we looked at increased screen time, and these were like 8 to 12-year-old kids, increased screen time was related to the opposite phenomena. So reduce synchronization between this word reading region and other brain regions related to language processing and cognitive processing. So that was kind of the first evidence to say, okay, something is happening here. We know that we have 24 hours during the day, including sleep, eating, school, everything. If kids are not reading, they're doing something else. And this is why we conducted this study. But then, of course, the question is, well, when they read, let's say they read, but they read from the screen versus from a printed paper, is there any difference between these two conditions? So we conducted this study using EEG. As I said, it is impossible to measure this, to answer this question using MRI. And we found that when children were reading from a printed paper, they had lower cognitive load, which means that they had lower distractions versus a condition that they read, of course, a different story from the screen. Now, we went back to the literature to see if this phenomena was reported. And in adults, there are some behavioral studies that did not use MRI, but also showed that adults that are reading from the screen versus from a paper report that A, their comprehension was lower, so they understood less when they read from the screen, and B, that the way they processed the information was different. So their eyes moved differently on the screen. They could not focus on specific parts of the paragraph that they read. So there is something different in the way we process information from the screen versus from a paper. And this is something that definitely warrants an additional in depth investigation.
Are you looking at things like executive functioning networks of children as well as when reading from or using screens?
So we definitely look at executive functions, which is again also referred to as cognitive control, our frontal regions that you talked about reading earlier. This is the network that connects everything, puts everything together. I call it the captain because it takes charge of all the other networks in the brain. And in our studies, we look a lot at this network because it also heavily related to the attention network in the brain. And what we keep seeing is that the existence of screens around us. So even now, when I'm talking to you and I have my phone next to me, I'm kind of gazing to it here and there. What does it mean? It means that my executive commander, the captain, kind of directs the attention to look at it a little bit. And then my attention is directed from what I need to be focused on. This is a problem. So we are looking at how well the executive network is able to monitor cognitive processes. And we see that with the existence of phones or smartphones, either while children are performing a task or even when parents are getting some notifications to their phone when they are interacting with their kids. So they are doing a good thing, but the phone is there. It is distracting our attention, and we cannot resist. It pushes me to say what to do, but I will wait till the end. We need to take it away.
I wanna go back to what you said at the beginning about white matter and gray matter and interactivity and connectivity, and you just mentioned the captain, which is in the front of the brain, and it gets more and more effective over time, right? So we talked about little kids, now we're talking about older kids, and you and I both are thinking about the parents listening right now, and they're one how do you apply all of this? As children get older, can you talk to them about the captain? Can you help them understand the different regions of the brain as a way of both encouraging them to push harder, say, with print media versus screen media, or to understand why sometimes things are harder and get easier over time? And I want to do that. I want to have you back up and tell us about all that connectivity and activity and how the front of the brain over time helps us manage all of that in all that stimulation and all that learning.
So, what I can say is that our everyday, our life are full with stimulation. All of it. From the moment I wake up, when I hear the horns outside, and when someone is calling my name, and in my brain, I kind of think, okay, today I have this, this, and this. And, oh my God, I'm late. So what do I need to do? I need to brush my teeth, rush really quick. I need to grab a sandwich because I will be hungry later. All of that is what is running in all of our brains. Now, if this, with all the additional information that is happening in the environment, will go in and run in this loop, we will not be able to function. And that's why we have some sort of a filter, which is our attention system, to filter in everything that is very, very crucial for us and filter out everything that is unrelated to us. So if there's a barking dog outside of my apartment, and I keep hearing this barking dog, and it's not even mine. And I need to be focused on something, and I cannot tell myself, okay, ignore, I won't be able to function. Our attention system is super, super critical. Now, think about all the challenges that are happening, and as a young child, and I will say that the attention system develops over time, and this captain that monitors it reaches the full maturation at the age of 26. So late in life. So I have this challenge of immature captain, and I have my attention system that is very, very overloaded. And then I also have my smartphone that keeps kicking and putting notifications on and keeps reminding me that, hey, this one sent me a message. Hey, this one liked my post. Hey, this one went to tell me something. How will I manage all this information? It is really impossible. Now, we are doing this as adults. Our captain is already mature. Maybe it's even getting older a little bit, but it's already mature. And our attention system is well trained to know what is critical for us and what we need to kick out. Those with ADHD with attention difficulties are having really hard time to even screen what's important or not. Everything is very important. And if we add on top of that, also a buzzer that keeps sending us notifications, we won't be able to focus on what we need. And so I think that this is how we should treat smartphones and other devices, even on our own computer. If you have your notifications on your computer and every time you get pops, it is really impossible to remember what you wanted to do. And I think having this kind of conversation with teenagers totally makes sense. I mean, you can even try just as a trial, just as an experiment, 30 minutes with it and 30 minutes without, and feel on your own, on yourself, how it feels without these notifications and whether you were able to focus more on your homework or anything else that you wanted to do.
Revisiting this idea about teaching kids about how their brains work, is it enough to understand that our captain is still maturing to actually be able to do something about how we interact with our screens? Or do we need more of these structural barriers that you just suggested, like turning off notifications to support us in controlling our use?
I believe that, first of all, I am a really great believer in modeling. So, parents, I believe, should also model this behavior, including showing their children how they themselves shut down the notification. And I believe that if children see their parents, I mean, this is a very basic first classes in cognitive psychology, developmental psychology. Children mimic their parents' behavior. If the child sees that the parent is able to put the smartphone aside for dinner, because this is dinner time and we're having a conversation, or if the parent is putting the smartphone aside when they're doing a very, very important work, then the child feels that it's totally okay to do the same. So I think that A, definitely can talk to a child and explain. B, model yourself and show the child that is possible. C, embrace the child that he or she were able to do that, you know? So definitely go for it.
Are your results and methodologies from the fMRI and the other tools you're letting us know about causing brain activity or structural changes versus the children in these studies just having different brains to start with?
This question is a little bit challenging to answer because to see if there is a direct effect on brain activation, we really need to run a longitudinal study and to track children from birth and to quantify exactly how much screen that they were exposed to, and then have this long study showing A to Z and all the effects of screen and everything that they were exposed to. I think that there are studies that are started getting into this direction, but unfortunately not neuroimaging studies, so it's hard to answer. I can tell you that children can probably these days, their brains are wired differently. They are able to process information in a very, very fast manner, multiplied by 2, by 3, by 4. Is it also an in-depth processing? I'm not sure. There is a limit of how fast you can transmit the information and still comprehend deeply the information that you receive. We are currently running a study that we wrapped up, but I haven't analyzed yet. So I'm super, super excited to look at the results of administering a story that was handed to participants in the scanner with a regular, voice speed, regular speech, and multiplied by 2. And I want to really see whether there is a higher attention, but also engagement with language related regions. Were they able to imagine the story when it's multiplied by 2 or not? And I believe that will tell us if the quality of understanding and engagement in a multiplied by 2 condition is similar or not to multiplied by 1, so a regular speech level. I think that the brains of children is processing information differently. They're able to multitask, and I do this because we do not really multitasking. We are doing one thing, and the other thing that we're doing is with half level of cognitive investments. So it's not as good in quality. And I always ask my colleagues, so would you like a student that was trained in medicine to operate you if everything that they learn in the class was multiplied by 2 or 3? Or would you like to be operated by someone that read deeply the information and practice everything as they should? And I think that the answer is very clear here.
Great analogy. Will you please call us when you're done with that study and so we can have another conversation about those findings?
Absolutely.
You've done research involving children with dyslexia and ADHD. Are you finding similar patterns or effects to brain activity and connectivity from exposure to screen media for children with those conditions?
So in our studies, we find that children with developmental difficulties, such as dyslexia, for example, engage differently their brain networks related to reading when they are exposed to an excessive screen time versus reading time. So, we have approximately 24 hours per day. For some of us, maybe they win another one, but we have 24 hours per day and we sleep, we eat, we do all other activities. And there is a certain amount of time that children have for their hobbies, for their reading, for their other activities, including screen time. So, in our really earlier studies, we were looking at the relations between screen time and reading time. And for children with developmental difficulties like dyslexia, we found that increased screen time in relations to reading time was related to a different engagement of their cognitive control networks or executive functions or the captain that we talked about earlier. And remember that these networks are really in charge of monitoring and synchronizing our sensory system that is related to perceiving the whole world, and more particularly the reading related networks like visual and language related regions. So it is critical. And so I think that in children with developmental difficulties, making sure that screen time is not too high is of even an increased importance, because they do need to continue practice the abilities that maybe need some extra practice.
Another important piece of research I find fascinating is where you studied brain activity of children when a smartphone was just present in the room, as opposed to actually being used. Can you share a little bit more about what you learned in that study?
Yeah, so in that study, again, several of my studies are inspired by just looking at human behavior. And I noticed that some children, you know, understand that when they're using their phones while doing their homework, it is not really official for their homework being conducted in a good way. So they just put it aside and they say, well, it's just there. Now, I'm rewinding our conversation about attention and how much it needs to be filtered to external stimulation that are coming into our system. And so we wanted to see if just the existence of phone in your environment while you're doing an activity that was not that hard. It was basically a very simple cognitive task. Kids need to push one button when they see red car and another button when they see a blue car. So it's not really, really hard. And they had to do that as fast and accurate as possible. We found that in the smartphone presence condition versus the non existence condition, children showed a higher cognitive load. And a higher cognitive load meaning we need to work hard in order to take out the distractors that we have. Now, I was really worried when we saw these results because it means that if the task would be a little bit more challenging, maybe it will be even harder to disengage and not to even look at the phone. We believe, and that aligns, by the way, again, with behavioral studies that did not use neuroimaging, that showed that the more distant the smartphone was, the better was the performance in the task. So this is not something that we made up. That was something that was validated before. We just kind of showed the mechanism, probably. That means that there is a distraction, an overload on our attention system to try to get a, to take out all these thoughts of, did someone reach me? Did someone call me? Did someone text me? And to focus on the task.
What led you to this field of studying screen effects on brains? Did you have an aha moment at any point in your career that led you down this path?
I started looking at that deeply when I started having children. And as I said, I'm originally a reading researcher. I research reading and neurobiology of reading. And when I started having my little kids, I read books for them. But when I read books for them and I felt really good about myself that I'm investing time in my kids and I'm nurturing their young brains, I always had my phone next to me, you know? So here and there, someone would send a message and I will take a quick pic. And I remember how frustrated they were when I was looking at the phone. And then they wanted to grab it and take it away from me and take a look at that. And I thought, it makes sense for them. They should be the most important person in the world for me. And they are. But I am looking at something else while interacting with them. So what do they understand? They understand that there is something that is more interesting and more important, and they want to take a look as well at this thing. So what I'm trying to say is that this moment made me think about what is happening when it's present, what is happening to my attention as an adult when it's present and I'm communicating with someone else, what is happening to the child in front of me. Did I break this very special connection? And we talked a lot about synchronization between brains. Are we back into sync after I gaze for a really short time, but then I'm here, I'm back? Is the child back? Are we back again into our special moment? And that kind of led me to a world full of questions. And with the speed of technology progress and development, I think that more and more and more questions are evolved and coming out, especially in the AI era.
I'm sure so many parents and caregivers listening can relate to that very natural distraction and activity on your part, and the guilt maybe even that comes up when you realize that you've done something just momentarily to disrupt that important connection to your kids. Do you have more information or findings from your research that you think parents would find useful? I mean, we've touched on having conversations about how the brain works, and we've talked about turning off notifications. What do you think the key takeaway is for protecting children's brains and their development and health vis-a-vis screen media?
Well, I have so many things that I want to say, but I know that I need to say the most important things that it will stick. So I will say togetherness. The togetherness is the key. When you're with your child, be with your child. If you have 5 minutes and not 10, and you really, really want it to be 10 minutes with your child, stay for 5 minutes. But for these 5 minutes, stay with your child and put aside your phone. If you're not a physician and someone is calling you really, really sick, it's okay that you will be 5 minutes away from your phone. And these 5 minutes will be so valuable for your child that it will be the world for the child. And the child will learn that there are some circumstances that worthwhile to put their phone away when they're teenagers and even when they're 5 year olds or even three. And you know what? Even with your spouse, put it aside, be together, look at each other, have a conversation, and let this distractor that brought so many good things to our life, right? Navigation and information, and now AI, and so many things, so much information, but it does not replace the human connection, and it will never do. So put it aside and have a togetherness time.
Thank you, Zippy, for sharing your important research that's helping us understand how screen based experiences may be shaping the developing brain in distinct ways that affect behavior and overall cognitive development. If you'd like to learn more about the research discussed in this episode or explore evidence based resources for families navigating digital media, visit childrenandscreens.org. And if you found this episode helpful, please consider subscribing to Screen Deep or sharing it with someone who thinks carefully about children, technology, and mental health. I'm Kris Perry. Thanks for listening, and we'll see you next time on Screen Deep.